All right, so here's lesson 2. Lesson 2 is about finding sides using trig ratios. Remember that I'm going to use the one calculator that's provided through self-service. If you're using a different calculator, please remember that you're going to have to be responsible for figuring out how it works. So the first thing we want to do is find the length of a side given an angle and one other side of a right triangle. So let's start with a good old right triangle. Let's call this theta. Let's call that theta. And let's say that this is 8 and this is 14. The first question I would ask you is that sine, cosine, or tangent? And you would say, I have the opposite side and I have the adjacent side, so this will be called tangent, and that would be 8 over 14. Then we would use our handy-dandy calculator. So since I'm working backward, I want to make sure that I'm in the a sine, a cosine, a tangent part of my calculator. I'm going to click on a tan, and I can type in exactly what I have, 8 divided by 14. The measure of theta then is 29.745 degrees. I just want to make sure we remember what we were doing last class as we move forward into this class. Okay, so let's just move the calculator out of the way for a second. So that's how I would find a missing angle. Now, how am I going to find a missing side? Well, let's get ourselves a different triangle. Go ahead and make sure it's a right triangle. And let's call this 37 degrees. Let's call this X. And let's call this one down here 14. Apparently 14 is the popular number today. Well, first question, is this sine, cosine, or tangent? Well, 37 is opposite from X, and 14 is called it's called the hypotenuse. So what we would do is we'd say sine 37 is X over 14. Now we just have a happy little equation. How do I isolate X? Agreed. I'm going to multiply both sides by 14. Now let's grab our calculators again and clear it out. Since this is regular sine, I need to make sure my calculator says regular sine. So see, regular sine. Now in my calculator, I'm going to type 14 sine 37. And the length of X, so that's what this means, X is 8.425. That might be feet, that might be meters, we don't know because we weren't given a unit. Okay, so let's try another one. Let's do a long skinny one. Do a real long skinny one. Okay, let's try that again. Okay, last time, and then I'll draw a different style. Yep, I have to draw a different style. But here's what you're noticing. I did not give up. There we go. So now we have a long, skinny right triangle. We'll make this 21 meters. We will make our angle 8 degrees. So you'll see your math like this sometimes. When we can't squeeze the number into the angle, we'll just draw an arrow. You need to find sides X and Y. So you need to find both sides X and Y. If I look at X in relation to angle 8, is that sine, cosine, or tangent? Well, I have the hypotenuse, and if I have the hypotenuse, it has to be sine or cosine. X is opposite from 8, so this would be sine 8 equals opposite over hypotenuse. And then we're going to solve that one. But before we solve that, let's go ahead and set up for y. What's the relationship between y and the angle? It's not opposite, and it's not the hypotenuse, so it has to be correct. It's adjacent. So since it's adjacent, cosine of 8 degrees is going to be y over 21. Now we're going to grab our calculator, maybe. Here we go. And clear everything out. Make sure we're in the regular numbers, which we are. So the first thing we're going to do is we're going to multiply both sides by 21, and we'll type in 21 sine 8. X is 2.923 meters. It's tiny. Does that make sense looking at our triangle that x would be very small in relation to the hypotenuse? What do you think y is going to be? About how long do you think y is going to be? Well, let's find out. We are going to type in 21 cosine 8 equals y, because I multiplied both sides by 21. Clear 21 cosine 8. Well, look at that, 20.796 meters. It's almost the same length as the hypotenuse. Does that make sense? Right, because the angle is so very, very small, it does make sense that that's going to be 8 degrees. Let's see, I want to solve for angle beta. How would I find the measure of angle beta without doing trigonometry? Correct, 180, because that's how many degrees is in a triangle, minus 90 minus 8 degrees. So that's going to be 82 degrees. Very good. How can I prove that B is 82 using trigonometry? Well, I know x and I know y, and x and y in relation to B would give me what? Sine, cosine, or tangent? It would give me tangent. So tangent of beta would be equal to y over x. Tan beta would be equal to 20.796 over 2.923. Will I use the regular sine, cosine, and tangent, or do I need to use the other ones? I need to use the other ones because I'm going to be solving for the angle. See that A that's in front of sine? You can think of that as saying, find me the angle given the ratio. A stands for angle. That might help. So in my calculator, since this is, I want to arctan it, or find the angle from tan, I'm going to say A tan, and remember, I'm just going to type in the numbers I have. I don't need to estimate first and then type them in. And the answer is 81.999, or approximately 82 degrees. Guess what? That's pretty darn awesome. Let's check our objectives for the day. We found the length of a side. We proved using sine and cosine that the lengths of a side of a triangle are correct. And then finally, we're going to find the perimeter. So this is our last problem. Let's go ahead and make a happy big old right triangle because they're easier to use when they're bigger. And we're going to make this, what do you think, 37 degrees. Yeah, that sounds good. I want to make things a little more challenging this time, so I'm going to make the hypotenuse a variable. Let's make the hypotenuse stand for h. And then I'm going to make this side down here on the bottom, 19 feet. Your instructions will be find the perimeter. Now the perimeter, of course, is all the sides around the triangle. Right now, I'm going to ask you for the hypotenuse first, but then you will have to find the third side. What is 19 in relation to 37? It's adjacent. And then I have the hypotenuse, so adjacent and hypotenuse is cosine. The cosine of 37 degrees will be 19 over h. This is where some of us got lost in the algebra before break, so I just want to write out all the steps again. Remember that when a variable is in the denominator, I can't solve for it. Instead, I have to set up a proportion. 1 times 19 is going to be equal to cosine 37 times h. I'm going to put the h first, and you're going to see why here in a second. Now remember, the whole point of solving for a variable is that you get the variable alone. Therefore, I have to divide both sides by cosine 37, which we know is just a number. Cosine 37 isn't anything mystical. It is simply a number that we find with our calculator. These values go away, and then I can just use my calculator. Remember, is this regular cosine or find an angle cosine? This is regular cosine. So in my calculator, I'm going to type 19 divided by cosine 37. My answer is the h value, or the hypotenuse, is 23.791. So 23.791 is my hypotenuse. And it's feet. So some of you may be thinking, well, okay, so now I'll use the Pythagorean theorem to find that missing side. Here's why we do not want to use the Pythagorean theorem. I have estimated the length of the hypotenuse. If I find the missing side using Pythagorean theorem, I'm going to be using an estimated value. I want to be more precise than that. So what can I use trigonometric style to find that missing side? And let's call this, I'm going to call it M for missing. What ratio would I use if I'm going to use M and 19? Is that sine, cosine, or tangent? Sine 37 degrees is equal to the missing side divided by, oops, that's not sine. Stop me. It's not sine. What is it? Right, it's tangent. I'm sure at least one of y'all caught me. So it's tangent because it's opposite and adjacent. How did I know that I was doing something screwy? Because sine and cosine use the hypotenuse. And since I was specifically telling us we cannot use the hypotenuse, it could not be sine. It's just often I notice students like to use sine anytime they see that they're using the opposite side from your angle. Go ahead and finish solving that in your calculator. Get the answer before I do. So clear it out. It's regular, so it's going to be 19 tan 37. So 14.318. There you go. Now, can I find the perimeter now? You're right, I can. I can find the perimeter by adding the hypotenuse to the missing side to the side that I was given. And you know how to add those together to find your perimeter.